Today we're going to talk about solving problems with transversals. So our learning target is I can solve problems using properties of parallel lines. Okay, now just to recap, parallel lines are two lines that never meet. So these would be parallel lines, and a transversal is a line that intersects those two lines. Okay? And then we have certain angle pairings with lines that have transversals, and these are the types of angle pairings. And when the two lines are parallel, then our angle pairings have special properties to them. This was all covered in the last lesson, so I'm not really going to go over those special properties during this lesson. Alright, so the first problem we're going to solve is this one right here. And so the first thing I'm going to do to solve this is I'm going to write whatever equations I can come up with using my properties of parallel lines. So this and this is a linear pair, so my equation would be that one part plus the other part equals 180 degrees. Next, I notice that this part plus this part is also 180 degrees because these are consecutive interior angles. Consecutive interior angles theorem says that consecutive interior angles are supplementary. So now I have this part plus this plus the other part is equal to 180 degrees. Alright, and then the last equation that I have is that this angle is equal to this angle because these are corresponding angles. See, corresponding angles right here, and corresponding angles are congruent. So again, I'm going to put one part is equal to the other part. Okay? And then next, what I notice is that every single one of my equations has both an x and a y. So there's no easy way for me to solve for x because it has two variables. So in order to solve for both variables, then I have to use either elimination or substitution because two variables, and that's a system of equations. Initially, it might look like we could easily use elimination because there's a 2x here and a 2x right there. The problem with that is that there is also this x over here. So if we combine like terms, then that's actually 3x in this equation and 2x, so that would make elimination a little bit difficult. So I think I'm going to use substitution because this x is already like on its own. All I have to do is move this 3y over, and then I could easily substitute in either one of those equations. So that's what I'm going to do. I'm going to go ahead and get that x by itself, and so I have to subtract 3y from both sides. And then I get x is equal to 2y plus 20. Alright, now did I solve for x? No, because it still has the y in it. I need to actually get a numerical value for x. But what I can do is I can use this x and plug it into one of these two equations. I think I'm going to use this one because yeah, x is already right there. I don't have to worry about the two separate x's that need to be combined. So that's the equation I'm going to choose. So 2x plus 30 plus 5y plus 20 equals 180. So in the next step, what I'm going to do is plug in this where that x is. So I get 2 times 2y plus 20 plus 30 plus 5y plus 20 equals 180. Next step I'm going to take is I'm going to go ahead and I'm going to simplify this. Alright, so I'm going to distribute. I'll get 4y plus 40, because when I'm distributing, I'm multiplying by both of these. Okay, and then I got plus 30 plus 5y plus 20 equals 180. I'm going to continue to simplify, so I'm going to combine my like terms. So I have the 5y and the 4y, so that's 9y, plus 40 plus 30 is 70, plus another 20 is 90, equals 180. Okay? And then next, I gotta solve for y. So I'm going to subtract this 90 from both sides, and I get, I'm going to move it over here since I'm running out of room. I got 9y is equal to 90. Alright, and then divide by 9 on both sides, and I get y is equal to 10. So I solve for y. Am I done? No, because I still have to solve for x. So to solve for x, I'm going to take this y, and I'm going to plug it back in right there. Okay, so I get x is equal to 2 times 10 plus 20. So I just plugged that 10 in where the y was. So that means x is equal to 20 plus 20 equals, x is equal to 40. So now I solved for both x and y. I'm going to go ahead and plug my answers in right here. I got x equals 40. I got y equals 10. Alright, and the last thing I'm going to do, this one's not absolutely necessary, but I like to do it with a systems of equations type problem, is I like to plug in my x and my y on on one of the top equations to see if everything equals out. If everything makes sense, then we got the right answer. So the one I'm going to use for this, I'm going to go ahead and use this first equation that we have, because I haven't used that equation during my solving process. So this one makes sense as a check equation. So I have 2x plus 30 plus x plus 3y equals 180. So that means I have 2 times 40 plus 30 plus 40 plus 3 times 10. And what equals 180. What I did right there is I just took my x and my y values and I plugged them in here where they go. So that means now I get, when I simplify, I have 80 plus 30 plus 40 plus 30 equals 180. Alright, so now let's see if this makes sense. So 30 plus 30 equals 60, 60 plus 40 is 100, 100 plus 80 equals 180. So I have 180 equals 180. Yes, check. I checked that my answers were correct on that. Next we have this page, and we're solving for these x, y, and z values. This time we don't have to use systems of equations. There's a simpler way to do things. I can recognize that this 2y is equal to this 18 degrees because these are alternate interior angles. So I'm going to go ahead and say 2y is equal to 18 because because alternate interior angles just divide by 2 on both sides, and I get y is equal to 9. Alright, next I can solve for x. I have this 3x right here plus this 18 right here can make a consecutive interior angles right here with the 63. So this plus 63 equals 180 because of consecutive interior angles. So 3x plus 18 plus 63 equals 180 because consecutive interior. So then combine like terms, I get 3x plus 81 is equal to 180, subtract. I get 3x is equal to 99, divide by 3 on both sides, I get x is equal to 33. And then next, what I'm going to do is this 3x right here, we just said 3x is 99, so I'm going to put a 99 right there. And that's also going to be alternate interior angles with this 11z. So I'm going to go ahead and say 11z is equal to 99. And then just divide by 11 on both sides, and I get z is equal to 9. Now I just got to plug in where everything goes. There we go. This one was much simpler than the systems of equations problem. Alright, next I have this problem right here. Well, I know that this x and whatever this angle is, those are a linear pair. And these are alternate interior angles. See? So I'm going to go ahead and put my 3x minus 40 right there. And this plus this is 180 because it's a linear pair. So 3x minus 40 plus x equals 180 because linear pair. Alright, 3x plus x, that's 4x minus 40 is equal to 180. Now I'm going to add 40 to both sides, and I get 4x is equal to 220. Divide by 4 on both sides. I get x is equal to 55. Plug it in here. That one's that. Alright, next these crooks problems, they can get a little bit tricky. For these problems, what I'm going to do is I'm going to go ahead and draw a line here. With this line, I can see that this angle right here is going to be equal to the part of that x angle. This angle right here is going to be equal to part of that x angle because of alternate interior angles. So I'm going to have to figure out what this angle is. So I see that this angle, these two are equal because vertical angles. So this angle I got to solve for. I'm going to do 180 minus 165, and I get 15. So that's 15 right here, 15 right here, and because of alternate interior angles, that means it's 15 right here as well. Okay, that part of the x. Okay, next, same thing right here. Alternate interior angles right here. So 180 minus 125 is equal to 55. So that means that this angle is going to be 55 because supplementary angles. This angle right here is 55 because vertical angles. and then this angle right here is 55 because alternate interior angles. So now that means this x is made up of this 55 and the 15. So 55 plus 15 is equal to 70. So x is equal to 70. Same thing goes for this one right here. It's a little less complicated because we already have one of our interior angles right here. So I'm going to make my line. So this angle right here is 59. Alright, now I just need that angle, which is alternate interior angles with this. And this and this, these are these are linear pair. So 180 minus 131 is equal to 49. So this angle is 49, which means that this angle is 49. Now 59, x is equal to 59 plus 49, which is equal to 108. X is equal to 108. Okay. And last page, now we're just doing a proof. We're going to prove that x is equal to 8 in this problem. So first we have that angle 1 and angle 2. Here's angle 1, this is angle 2. I know that because it's described right here. That they're supplementary, and the reason for that is same side interior angles theorem, also called consecutive interior angles theorem. Okay, next, instead of calling it supplementary, I'm going to say that they're equal to 180 degrees. That I'm using definition of supplementary for that. Okay, and then after that, I'm going to go ahead and say that 8x minus 4 plus 120 is equal to 180. And I know that because I just substituted in what measure of angle 1 and measure of angle 2 actually are. And then next I'm going to simplify, so combine my like terms. And I have 8x plus 116 is equal to 180. And then I'm going to go ahead and subtract this 116 from both sides. So next is subtraction property. And so then I get 8x is equal to 64. And then I'm going to go ahead and divide by 8 on both sides. So that's division property. So then I get x is equal to 8. It asked me to prove x is equal to 8. I got x is equal to 8. Yep, I did my proof correctly. Alright, next we have this is angle 1. And this is angle 2. I know that because it describes it right there. First thing, I have angle 1 is congruent to angle 2. How do I know? Well, they're alternate exterior angles. And I'm going to put that theorem there. So alternate exterior angles theorem. Alright, next I'm going to say measure of angle 1 is equal to measure of angle 2. What did we change? We just changed that congruent sign to this equal sign, so I'm using definition of congruent. Alright, next I'm going to go ahead and substitute in my values. So I get 14x minus 5 is equal to 5 plus 12x. I just used substitution property there. Alright, so the next thing I think I want to do is I want to move my numbers on this side and the x's over here. So first I'm going to move my numbers, so plus 5 on both sides. So I'm using addition property. So then I get 14x is equal to 10 plus 12x. Now I have to move the this 12x over here, so to do that I'm going to subtract 12x from both sides. So I used subtraction property. And I get 2x is equal to 10. Alright, last to solve for x, I'm going to go ahead and divide by 2 on both sides. So I'm using division property. And I get x is equal to 5. It asked me to prove that x is equal to 5. We got x equal to 5. I'm done with my proof.